Hello everyone. So we are going to start the next part. That is the part 10 from the topic Coarse dispersion. So in this part we are going to discuss regarding some of the auxiliary emulsifier and preservative which are used or which may be used in the emulsion. Afterwards we are going to discuss regarding the stability of the emulsion. So without wasting any time, let's start our presentation. So as I already told you, auxiliary emulsifier. So what are auxiliary emulsifier? You see, the auxiliary emulsifier, they are also known as the secondary emulsifier. These include those type of compounds which are actually incapable of forming a stable emulsion. They themselves, these auxiliary emulsifier, they never can form a stable emulsion. But what is their function then? Their function actually, as the name itself will say, it is a auxiliary. Means along with the main emulsifier, it will act as an emulsifier. Their main value lies in their ability to function as thickening agent. So they thicken the dispersion medium, and but by doing that, they stabilize the emulsion. So there are a number of emulsifier which are used as an auxiliary emulsifier. So let's discuss all this emulsifier in this given table. So you see, the number one, it is the cetyl alcohol. Cetyl alcohol, it is a lipophilic thickening agent. It is generally used for oil in water type of lotion and ointments. The next one, it is your glycerol monosterate. It is also abbreviated as GMS. So GMS, it is used as a lipophilic thickening agent, and similarly it is also used for oil in water type of lotion and ointments. The next one, it is your methyl cellulose. Methyl cellulose, it is also used for oil in water type of emulsion and weak water in oil type of emulsion. Then we have SCMC. SCMC, these are actually abbreviated. SCMC means sodium carboxymethyl cellulose. SCMC. Now this SCMC actually, it is also used for stabilizer for oil in water type of emulsion. And the next one, it is the stearic acid. So stearic acid also, it is a emulsifier or stabilizer for oil in water type of lotion and ointments. And it also from a true emulsifier when it reacts with the alkali. So if the stearic acid it is added with alkali, then definitely it will act as a true emulsifier. Okay. Now we have learned about the emulsions, right? Now the thing is that in the formulation of the emulsions, we need to add some preservative, right? This preservative will prolong the stability and acceptability of the emulsion. It will prevent what? It will prevent the growth of microbes in the emulsion, which is intended to be used by a patient. So this preservative, the ideal preservative should have some of the ideal characteristics. So what are the ideal characteristics? Number one, it should be less toxic. Number two, it should be stable to heat as well as storage. It should be chemically compatible. The preservative should not react with other ingredients. It should be reasonable cost, means it should be cheap enough, right? So it should be acceptable, it should have acceptable taste, odor and color. It should be effective against fungus, yeast and bacteria. Now the thing is that available in oil and aqueous phase at effective level of concentration. So it should be available in both oil and aqueous phases. The preservative should be available for both oil and aqueous phases at effective level of concentration. Now what is effective level of concentration? Effective level of concentration means the minimum concentration with which a preservative can inhibit the growth of microbes in the emulsion. Done? So the preservative should be unionized or should be in the unionized state. Why it should be in the ionized state? Because if it is in the ionized state, the preservative cannot pass through the bacterial cell wall or bacterial membrane, right? So if anything you want to pass through the bacterial cell wall, that should be in the unionized state, because the cell wall is made up of lipid. Clear? The next concept, it is the preservative, it must not bind to another component of the emulsion and form the clogs. It should remain as it is, right? So these are the actually ideal characteristic of the antimicrobial preservative, right? So let us discuss some of the antimicrobial preservative agents or antimicrobial agents. So acid and its derivative. Example, benzoic acid. Benzoic acid have antifungal property. It can be used as an antifungal agent. The next class, it is the aldehyde. Aldehyde, for aldehyde we have an example, that is your formaldehyde. This formaldehyde, they have a broad spectrum of activity. Broad spectrum means it can act against both gram positive as well as gram negative bacteria, right? Then we have the phenols. These are also known as the phenolics. So phenol itself, it is a broad spectrum antimicrobial agent. Moreover, apart from phenol, we have cresol, propyl p hydroxy benzoate. It is also known as PPHB or PHB. Then we have the quaternaries. So in the quaternaries, we have chlorhexidine and its salt, right? So they always act as a broad spectrum antibiotic. Apart from chlorhexidine, we have benzalkonium chloride, cetyl trimethyl ammonium bromide. And lastly, we have the mercurials. The mercurials, example, phenyl mercuric acetate. They have broad spectrum activity against both gram positive as well as the gram negative bacteria. Done? So antioxidants. So what are antioxidants? Antioxidants are used in the emulsions just to prevent the oxidation process, right? The aim of the antioxidant is to inhibit, is to halt the process of oxidation. So you see, so it can be prevented by oxidation, can be prevented by auto-oxidation. Generally it occurs with a free radical reaction in the emulsion, and this auto-oxidation can be prevented by, number one, absence of the oxygen. If we stop the supply of the oxygen, the auto-oxidation will be stopped. A free radical chain breaker, if we add a free radical chain breaker, it will stop the process of auto-oxidation, and by using a reducing agent. Done. Example of antioxidant, gallic acid, propyl gallate. So these are gallic acid, propyl gallate. They are used in pharmaceuticals as well as cosmetics, but they have a bitter taste. You should know that. The next one, the most acceptable one, it is the ascorbic acid. So it is always suitable for oral use product, right? Then we have the sulfites. The sulfites, they are also used for oral use products. And then we have the tocopherols. These tocopherols, actually they are used in the pharmaceutical as well as cosmetics. They are suitable for oral preparation. Example, dose containing vitamin A. Done. Now let's discuss regarding their stability. So emulsion instability, how the emulsion becomes unstable. So the thing is that the instability of the pharmaceutical emulsion may be classified as following. Number one, flocculation in the emulsion may occur. Number two, creaming. Number three, coalescence and breaking, right? Then phase inversion. So miscellaneous type of physical and chemical changes. So it will be better if I make you understand with some diagram. Let's go for it. So stability of emulsion, you see, physical instability. Number one, coalescence. Coalescence means the particle will join together to form a bigger particles. The droplets, the dispersed phase, they will join together to form a bigger droplets, bigger dispersed phase droplets. This will hinder the stability of the emulsion. So this is known as a coalescence, right? Number two, it is the creaming. Creaming means, as the name itself, it's a creaming, skimming of, it will come at the top. The oil droplets, they will come at the top, they will come at the top, and that dispersion medium, they will remain at the bottom. So this is known as the creaming. They will form a layer at the surface. This is creaming. Next is the flocculation. The particles, they are going to adhere together, smaller size, bigger size, together they are going to adhere together. This is the flocculation. And finally breaking, they will separate out. The oil phase and the water phase, they will separate out. This is known as the breaking, right? So again, if you see, why instability of the emulsion occurs? So we all know that emulsion is not a spontaneous process, hence emulsion has minimum stability. Why emulsion though it is not a spontaneous process? Because you see, this is a flow chart how the emulsions are made. You see, two immiscible liquids are agitated together, right? The polar phase, or you see the aqueous phase, and the non-polar phase, that is the oil phase, are mixed together, right? So one of the liquid will form the smaller droplets, right? The other get dispersed in the other liquid. So one will become the dispersed phase, another will become the dispersion medium, and that finally forms the emulsion. The reason of their instability is because these two phases are immiscible. These two phases are immiscible, completely immiscible. One, it is polar phase, or you can say aqueous phase, and another it is non-aqueous phase. So these two phases, as they are totally immiscible, thus you can say that emulsion, they don't act, or they don't act stable. They generally, the emulsion, they generally have minimal stability. So the physical instability, it includes, again I am telling you the same thing only, flocculation. I repeat, flocculation. Number 2, creaming and sedimentation. That is the coming at the top. It is known as the creaming. Sedimentation coming at the bottom. This is known as the sedimentation, right? Then we have aggregation and coalescence. This is known as aggregation. Bigger droplets. This is known as aggregation or coalescence. Then we have phase inversion. Now, what do you mean by phase inversion? Phase inversion is nothing but, you see, sometimes some criteria or some conditions occur. Suppose we have a oil in water type of emulsion, but due to the change in the physical attributes include temperature, humidity, pressure, anything like that, the oil in water type of emulsion may get converted into water in oil type of emulsion. Means their phase will get opposite. Earlier it may be oil in water type of emulsion, but later on it will become water in oil type of emulsion. That is known as a phase inversion. That is also counted under the physical instability, right? And finally the breaking, it is the breakdown of the two phases. So thank you everyone. I hope you have liked the video. If you like the video, just press the like icon. You can share this video and you can subscribe to my channel. Thank you once again.